Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel, Paper Bold, where we are solving past paper questions of IGCSE Physics 0625. Currently, we are doing the chapter of electricity and magnetism, and we've done quite a few topics up till now, and this is one of the last topics that we are going to do, which is topic 4.17, multiple topics, which comprises of questions related to many different concepts related to electricity and magnetism. So this is going to be a mixed bag. So let's begin. But before we start, kindly like and subscribe to the channel. And if you find anything helpful from these videos, kindly remember me in your prayers. Okay, so question number 1. The diagram shows a conducting metal rod PQ. In the magnetic field between North Pole and South Pole, the rod is connected to a resistor in a circuit. In which direction should rod PQ be moved to induce the current I in the direction of the arrow in the circuit? Okay. Whenever we are talking about induced current, we know that we have to use Fleming's right-hand rule for it. And the direction in which the rod PQ should be moved is given by the direction of our thumb, which represents the force. Okay? So if we look over here, north-south, this finger, the first finger is pointing towards north and south. Second finger is pointing towards the current, and our thumb gives us the direction of force, which is in the upward direction. So this is where the rod PQ should be moved to induce the current I in the circuit as shown. So if we look at our options A, B, C and D, we know that the force has to be in the upward direction. So we are going to select A for that. Question number 2. The diagram shows a current carrying wire in a magnetic field. In which direction is the force acting on the wire? Okay, now since this is a question that is not related to induced current, and we have to tell the force, and we've been given the direction of the magnetic field and the direction of the current as well, so we are going to use Fleming's left-hand rule. Okay, so our first finger is going to point in this direction. The second finger that depicts current is going to point away from us, and we will see that our thumb points in the downward direction, okay, according to this scenario. So in which direction is the force acting on the wire? Force is represented by our thumb, magnetic field is represented by this, and current is represented by the second finger. The force is being represented by the thumb, and it points in the downward direction. So it means that towards the bottom of the page, yes, this is the correct answer. Question number 3. What is the purpose of split ring commutator in an electric motor? A, to ensure that the magnetic field in the motor changes direction every half rotation. No, the magnetic field doesn't change. To ensure that the magnetic field in the motor stays the same in same direction at all times, but this is not the function of split ring commutator. To ensure that the turning effect on the motor changes direction every half rotation. No, the direction has to stay the same. So to ensure that the turning effect on the motor stays in the same direction at all times, this is the correct option. So D is our correct option. Question number 4. A wire XY is connected to a resistor R. The wire is moved in the magnetic field between two magnetic poles. In which direction must the wire be moved so that the induced current is in the direction? So again, there is a question related to induced current. So we are going to use Fleming's right-hand rule over here. And we can see that our first finger is going to point in this direction. Our second finger is going to point in this direction. Okay. And then we can always see that the thumb is going to point in the downward direction. Okay. So if we look at the options, so A, C and D are pointing in upwards, left and right direction. So B is the only option that is pointing downwards. So this is what we are going to choose? Question number 5. When a current carrying conductor is placed in a magnetic field, experiences a force. Which statement about this force is correct? It is parallel to both the magnetic and the direction of the current. No, that's not correct. All the three fingers are actually perpendicular to each other. So we will look for an option that states that B, it is parallel to the magnetic field and perpendicular to the direction of the current. No, this is not correct. It is perpendicular to the magnetic field and parallel to the direction of the current. No, this is also not correct. It is perpendicular to both the magnetic field and the direction of the current. This is correct. We know that if we use Fleming's left hand rule or we use Fleming's right hand rule, we know that the first finger points in this direction, second finger points in this direction, and the third finger points in this, our thumb actually points in this direction. So all the three fingers are perpendicular to each other. So D is the correct option, that the force is perpendicular to both the magnetic field and the direction of the current. This one shows the direction of magnetic field, this one shows the direction of the current, and the thumb actually shows the direction of the force. So it is perpendicular to both these fingers or direction of the magnetic or current. Question number 6. The coil in the DC motor is connected to a split ring commutator. What is the purpose of the split ring commutator? Okay, A, to ensure that the coil continues to rotate in the same direction. Yes, this is correct. We've just done a question before as well. Its purpose is to ensure the coil continues to rotate in the same direction. So A is our correct option. Question number 7. 4 positions of a current carrying coil in the magnetic field as in a DC motor are shown. In diagram 2 and 4, the coil is at angle 45 degrees angle to the field lines. Okay, which row is correct? Turning effective forces in position 1 and 3. Okay, this is position 1 and this is 3. Are different or same? They are different, because over here we have our maximum value and over here the value is 0. So it's going to be different. Okay, and as far as 2 and 4 are concerned, they both are at 45-degree angle to the magnetic field lines. So their turning effect is going to be the same. So I think B is our correct option, that states that 1 and 3 have a different turning effective force and 2 and 4 have the same turning effective forces. Right? Okay, moving on. Question number 8. The diagram shows a horizontal wire in a magnetic field. The horizontal wire is firmly held at each end and cannot move. The magnets and holders are on the balance. When there is no current in the wire, the reading on the balance is 0.35. This is a DC circuit in the wire. There is a DC current in the wire as shown. What happens to the reading on the balance? Okay, now the current is moving towards us and there is North Pole and there is South Pole, and we have to see that in which direction is the force being applied over here. So if we see that our first finger is going to point in the right direction, the current is going to point towards us. The second finger is going to point towards us when we are using Fleming's left hand rule, because there isn't a mention of induced current over here. So we are using Fleming's left hand rule. So the thumb is going to point towards the top, okay, towards the upper end. So if the force is being applied in this direction, according to Newton's third law of motion, there is going to be an equal and opposite reaction to this force, and there is going to be a force of equal and magnitude and opposite direction in the downward direction as well. So because of this force, there is going to be increase in the weight. Okay, because of this force. So if we look at the options, the reading is going to be smaller than 0.35. No, that's not correct. There is going to be no change. There is going to be change because the force is acting in the downward direction as well. Changing from smaller to larger than 0.35 repeatedly, no, this is not going to change because they've told us that it was in the other question. Larger than 0.35, yes, this is the correct answer because of this downward force acting in the downward direction, the weight is going to increase. Question number 9. Diagram 1 shows a wire carrying an electric current into the page. The wire is between the poles of the magnet. The force is produced on the wire acting down towards the bottom of the page. Diagram 2 shows the situation where the current is reversed and the magnet is turned through 90 degrees. In which direction does the force act after these changes? Okay, again, this is not a question related to induced current, so we are going to use Fleming's left hand. And if we see that our first finger is going to point in the upward direction, which shows the magnetic field. Okay, the current is out of the page, so this finger is going to be pointing towards us. Okay, how do I show that? Like this. It's going to point towards us, and the force is going to be towards the left side of the page. So thumb is pointing in this direction, which shows the force. This is the current that's pointing towards us. And this magnetic field is pointing in the upward direction. So our thumb points towards the left side, and it shows the direction of the force. So towards the top of the page is not correct, towards the bottom of the page is also not correct, towards the left hand side of the page, yes, this is correct. Okay, use your Fleming's left hand rule in the way I've just told you, and you are going to get to this answer. Okay. Question number 10. The diagram shows a wire carrying a current in the direction shown. There is a magnetic field acting from left to right. The wire experiences a force acting out of the page. Okay. The current is now reversed. In which direction does the force on the wire act now? Okay, we are going to use Fleming's left hand rule for this. Now we know that this is north, this is south. First, the direction of the current was in this direction. Now it's in the upward direction. So our first finger, which shows the magnetic field, is going to point in this direction. And our second finger that shows us the direction of the current is going to point in the upward direction. And you'll see that your thumb is going to point in the downward direction. वैसे भी, they've told us that the direction of the force was out of the page when the current was in this direction. So obviously, if the poles have not been changed, now the direction of the current is going to be opposite to what it was before. So it is going to be, firstly it was out of the page, so now it is going to be into the page. And if you use your Fleming's left hand rule, you will see that it points towards the down into the page. Okay, so both methods can be used to find the answer. It is going to be the same, that is into the page. So this brings us to the end of this topic. So inshallah, see you in the next video. Take care up till then, and if you found anything helpful in the video, kindly remember me in your prayers. Thank you and Allah Hafiz.